Okay, I got a newfound theory that I've been working on. Here's my pulse width modulator, and I'm trying to run two different voltages through it to enable me to use a higher voltage on my HHO cell. What I have here, I've got a small laptop power supply that has three leads coming out of it. We got the common ground, and then we have the yellow wire there going up to the tip of my test light. There is the 12 volt positive. The red wire coming out that's going into the pulse width modulator is 5 volt positive. If you look over here at my meters, I've got the main power line going into the pulse width modulators running 5.06 volts. Look over here, I've got nothing at the test light. So I'll come over here, I'll switch my pulse width modulator on. Okay. We'll come back over here and see the meters. We've got 5 volts positive going to the pulse width modulator. And I'll redo the connection here on my test light. Rust isn't always a good conductor. There we go. Okay. Now we've got nothing at the test light. Alright. Turn the dial. Watch. I must still have a bad connection here. Give me a moment while I check over my connections. It was working just a moment ago. There we go. Okay. Now let's try this one more time. I'm going to turn the dial up on the pulse width modulator. I get to glow on the test light, and now it's at full power. At the test light, you see my positive lead coming off the meter running down. Look over here, and I've got 11.47 volts going to the test light and 5.11 volts going into the pulse width modulator. The 5 volts is actually powering that little circuit there. It's a 555 IC timer, which is running 5 volt positive to the gates on the MOSFETs. And the common ground is the only thing switching. We're switching common ground between this terminal and this terminal, which this wire leads around to the end of the test light that's clamped on. I also have this monitoring the voltage. And I can adjust it. And if you let me move the meters to where you can see it all in the same picture. Okay. Well, so I can adjust it down. Still 5 volts on the pulse width modulator, nothing on the test light. Start to crank up the dial, and it slowly climbs, and it passes the 5 volt mark and goes on up to 12 volts. So that proves my theory that I can actually run two different voltages through my pulse width modulator using common ground for both power supplies. I can run my pulse width modulator on anywhere between 5 volts positive to 18 volts positive DC and have whatever amount of voltage that I want to run through my MOSFETs to the cell. I can have that run through the MOSFETs through the common ground. Because all it's doing is switching the common ground on and off at a different rate, depending on how far I turn this dial. That should enable me to adjust voltage I can hook up, say, 150 volts DC, which is in rectified house current, 110, 125 volts AC. With the bridge rectifier, you're going to get 150 volts DC. Add a smoothing capacitor to that and run that straight through the MOSFETs, and you can get a variable voltage anywhere between 0 and 150 and still be able to draw amperage. So once I get my cell built, that should run off of 110 to 150 volts DC and have at least an output of somewhere around 4 or 5 liters per minute. We'll see what happens. That's all for now. Signing out.